Hi everybody. Module 2, Lesson 8. Applying the properties of operations to add and subtract rational numbers. Students will be able to add and subtract rational numbers. So what are those properties? The ones we're dealing with today, commutative property, means that you can add or multiply in any order. 6 plus 3 is the same as 3 plus 6. They both give you 9. 2 times 4 is the same as 4 times 2. They both give you 8. Associative property means you can change the grouping. Those parentheses move. So in the marbles on the left, we first do 6 plus 3, 9, plus 4, 13. On the right, we're doing the 3 plus 4 first, which is 7, then adding on the 6. Still 13 marbles in all. The same idea with the blocks. The opposite of a sum is the sum of its opposites. This sounds a lot more confusing and a tongue twister than it really is. Explain the meaning of the opposite of a sum is the sum of its opposite. Use a specific math example. So I'm going to have us use the problem 7 plus -2. So the first rational number is 7. The second rational number in our problem is -2. What is the sum? It is 5. What is the opposite of the sum? Well, the opposite of 5 is -5. That doesn't sound too difficult. Opposite of our first rational number is -7. The opposite of our second rational number, +2. What is the sum of -7 plus 2? It is -5. They're the same. So the opposite of the sum is the sum of the opposites. You'll see why in a little bit. Represent the following expression with a single rational number. The single rational number, that just means solve it. That's all it means. So I'm going to show you two different methods. I'm going to explain both methods. Then I'm going to give you an opportunity to pause the video and copy down. I don't want you copying both methods down, but I want you to see the difference between them. So let's look at this first method. What did I do? -2 2/5 plus 3 1/4 minus 3/5. I changed them to common denominators. That's the first step. Then I made them all improper. Well, the mixed numbers I made improper. Then I took my first two add-ins and I added them, -48 plus 65. And just carry down my minus 12 20s. Then I did the 17 minus 12 is 5 20s, which simplifies to 1/4. Seems like a lot of steps. Seems like a lot of place for mistakes to happen. Let me show you another method. It's new. It might be a little confusing at first, but in the end, I think you might like it. So the first thing I did was I changed my problem from subtraction to all addition. And that's what we've been doing for the last few lessons, so that's not new. Then I used the commutative property. I changed the order so that my -3/5 was right next to my fraction, my mixed number that had a same common denominator. Haven't done any calculations, just moved things around. Why did I do that? Because now I can take these two and add them together. Okay, so I added my common denominator add-ins. Then what happens? Oh, if I'm at -3 and I move to the right 3 1/4, I am at +1/4. It's a different method, but in the end, I kind of like it. I don't care which method you use, just giving you another strategy. You may now take a moment and copy down the one that seems to make the most sense to you. I will be using the one on the right through this lesson. Use the number line model shown below to explain and write the opposite of 2 2/5 as a sum of two rational numbers. Well, let's start with 2 2/5. I'm going to break that apart. 2 plus 2/5 really is 2 2/5. And on the number line, I move to the right 2, and then I move a little bit more, and I am at 2 2/5. Well, let's look at the opposite of 2 2/5. Inside the parentheses is still the 2 plus 2/5. But this negative on the outside, means, where's my green pen? Opposite. When it's a negative on the outside of parentheses, it means the opposite of everything inside. So I'm going to move to the left 2, and then a little bit more to the left. They are the same distance away from each other. So I'm trying to show you that the sum of the opposites corresponds to the same point on the number line. I'd like you to pause the video and try ABC, and then resume the video. How did you do? Maybe you weren't quite sure what the question was asking, but now that you look at it, does it make sense? If I move to the left 9 5/8, I'm moving to the left 9, and then I'm moving to the left another 5/8. And the same thing for these other two problems. Just breaking the mixed number apart to be a whole number and the fractional part. But the signs remain the same as what the sign for the mixed number is. Why don't you pause the video and try exercise 3, A, B, and C. How did you do? All we're doing now is reassembling, combining our whole number with our fraction and keeping the sign. If I move to the left 1, and then I move a little bit more to the left, I've moved to the left 1 5/12. Why do we need to do this? You'll see in a few moments. Okay, Mr. Mitchell lost 10 pounds over the summer by jogging each week. By winter, he had gained 5 1/8 pounds. Represent this situation with an expression involving signed numbers. What is the overall change in Mr. Mitchell's weight? So using our new strategy, I'd like you to pause the video and try this problem. So first of all, if he lost 10 pounds, that's -10. And by winter, he had gained 5 1/8. So that means plus 5 1/8 equals something. So we're going to break apart our mixed number. So -10 plus 5 plus 1/8. Focus on this, which is -5 plus the 1/8. Well, I'm going to think about my number line. I'm going to move to the left 5. Then I'm going to move to the right just a smidge. And I land at -4 7/8 pounds. Well, that's good. Mr. Mitchell is still down by the end of winter. Jamal is completing a math problem and represents the expression -5 5/7 plus 8 minus 3 2/7 with a single rational number. Remember, single rational number means just solve it. And he has shown the steps below. Justify each of Jamal's steps, then show another way to solve the problem. We're actually not going to show another way, but I do want to talk about each step that Jamal did. So first, he changed the subtraction to addition. because we want to be able to have our problem entirely addition. Next, he used his commutative property. Look at how these two are now right next to each other. Why did he do that? He wanted the common denominators together. Next, he did opposite of the sum is the sum of the opposites. So he took the negative 5 and 5/7, and he changed it. He broke it apart, and he took here's the color one. He took the negative 3 and 2/7 and broke it apart. Next, he used his commutative property again. He put the two fractional pieces together. It's all addition, so we can move things around as needed. Now that the two fractional pieces are together, he used his associative property. He doesn't need to go left to right because it's all addition. He took those two fractional pieces that have the same denominator, and he added them together to get -1. Now it's all whole numbers. So what does he do? He just adds. And he got an answer of -1. So that's where we're going to stop today. I'm sure you have questions after this lesson. So make sure you play the video again, jot down any questions you still have, and we'll talk about them in class. See you then. Bye.